So my research question, is there a proximity relationship between assault crimes and the public transportation system in Portland, Oregon? The project measures the concentration of assault crimes near Portland's public transportation network. A location quotient method of analysis is performed at the macro, meso, and micro levels. And the study analyzes and compares 5 years of crime data between 2015 and 2019. The study area for the project is Portland, Oregon. Portland is approximately 145 square miles and is located on Oregon's northern border with the state of Washington. In 2015, Portland's population was 612,206. And in 2019, the population was 645,291. So Portland's population increased by 33,085 people during the 5-year study period. The transit system in Portland is operated by a public agency called TriMet. It operates buses, light rail, and streetcars. The entire TriMet network extends beyond Portland city boundaries and into other cities and towns in Multnomah, Clackamas, and Washington counties that make up the greater Portland metro area. Within the city of Portland, the TriMet network consists of 3,625 stops, 6 transit centers, and 16 park and ride locations. The crime incident point data that is used in this project is published by the Portland Police Bureau and is available as CSV files. And what I'm showing you here is a map of unclassified incident point data for assaults in 2019. I should note here for you that a point or an incident point can actually represent more than one offense. And the statistical analysis that was performed in the project is on offense counts and not incident points. There were some limitations with the data. The crime point locations are not exact. Crimes that occurred at an intersection are mapped to the centroid of the intersection, and crimes that occurred at specific addresses were mapped to the block midpoint. And also, there was an average of 3,155 incident points in each year of data that were unusable due to a lack of XY coordinates. The other data that was used for the TriMet features on the transit network, there were point and polyline shapefiles for the stops, centers, park and rides, and the routes. The Portland City boundary and the major water body features were polygon shapefiles that I downloaded from the Oregon Metro Regional Land Information System website. And the neighborhood polygons were downloaded from the City of Portland's Open Data Portal. This analysis was performed at 3 levels, the macro level, the meso level, and the micro levels. At all 3 levels of the analysis, each offense type was studied separately. And for the macro level, the crime incident points are aggregated to the City of Portland's boundary polygon, and location quotients are calculated for offenses using a 500-foot buffer within 500-foot buffer around the transit nodes throughout the entire city. For the meso level analysis, location quotients are calculated using a 500-foot buffer around transit nodes in 5 neighborhoods, and the crime incident points were aggregated to the neighborhood polygons, and there were 5 neighborhoods that were studied. And for the micro level of analysis, location quotients are calculated using multiple ring buffers of 4 distance bands with 250-foot intervals at 5 street intersections, and the crime incident points were aggregated to buffers around the transit nodes at those intersections. So what is a location quotient? The location quotient for this project was a method for quantifying the concentration of assault crimes per square mile within a buffered area around transit nodes and compared to the concentration of assault crimes within the larger study area. So at the macro level, the larger study area was the entire city, and the area of interest would have been the 500-foot buffer around all the transit nodes. And at the meso level, the greater, larger study area was the neighborhood polygon, and the area of interest was the buffered area around the transit nodes within the neighborhood. And at the micro level, the larger study area was the 1,000-foot buffered area around the transit nodes. And again, the areas of interest were the 250-foot distance bands of the multi-ring buffer that grew outward from the transit nodes at those intersections. And here is the location quotient formula. So in the numerator, you have little c divided by little a. Little c is the number of crimes in the region of interest, which is the buffered area, and the measured area of the buffered area. And in the denominator of that equation, you have big C divided by big A, big C being the number of crimes throughout the entire study area, and big A being the measured area of the entire study area. So interpreting the location quotient values. So if you have a location quotient value that is less than 1, that indicates that the concentration of crime per square mile in the area of interest is less than the concentration of crime in the larger study area. Location quotient values that are equal to 1 indicate that the concentration of crime per square mile in the area of interest and crime concentration of the larger study area are equal. Location quotient values that are between 0.9 and 1.1 are considered to be comparably similar. And the concentration, the location quotient values greater than 1, the concentration of crime per square mile in the area of interest is greater than the concentration of crime in the larger study area. And there is a threshold value. The threshold location quotient value indicates where concentration of crime in the area of interest is significantly higher than the study area. So for this project, a location quotient value of 2 indicated that the concentration of crime is 2 times higher than inside the area of interest when compared to the large area, and that was established as the threshold. So these 3 map figures just are a visual aid to show you at the macro level how this was performed. And you have the red dots or points on this first figure represent the aggravated assaults, and this data is from 2017. The orange dots on this map figure are the simple assaults. And the blue points on this map figure are the intimidation assaults, also for 2017. So for the meso level analysis, we were looking at neighborhoods. And again, we used 500-foot buffers around the transit nodes. The crime incident points were aggregated to the neighborhood polygons, and a 500-foot buffer was created around transit nodes in the neighborhood. And again, we used the same color scheme. The red points, again, indicating aggravated assaults. The white area is the 500-foot buffer around nodes, and the blue area is outside of that buffer. Orange points are the simple assaults, and the blue points on this map figure are intimidation assaults. At the micro level of analysis, a 1,000-foot buffer is created around transit nodes at street intersections. And this buffer area serves as the study area for each intersection. A multiple ring buffer of 4 distance bands was overlaid on top of the 1,000-foot buffer. Each distance band is 250 feet, and 250 feet was chosen because a typical city block in Portland is around 250 feet in length. And the location quotients are calculated for each offense type in all 4 distance bands to evaluate how the concentration of crime varies across space near transit nodes. So on these first 3 map figures on this slide, this is the 0 to 250-foot distance band. Again, the red points are the aggravated assaults. The orange points, simple assaults. And the blue points are the intimidation assaults. This next slide shows the 250 to 500-foot distance band. This is the 500 to 750-foot distance band. And the 750 to 1,000-foot distance band. So the results for the macro level analysis, the results produced location quotient values for each offense type that were consistently above the 2.0 threshold value. And these results indicate that assault crimes are more than 2 times more concentrated per square mile within 500 feet of public transportation nodes when compared to the rest of the city. For the Meso level analysis, there were 5 neighborhoods that were examined. Starting with the Buckman neighborhood, you can see that in every year, crime concentration levels for each offense type were higher than the surrounding area, but were below the 2.0 threshold. And for the Centennial neighborhood, a lot of them were actually well above the 2.0 threshold. Just a couple of them were below, but still higher. And for the Hazelwood neighborhood, you had a mixture of many that were more than twice as high, and while there were just 3 that were below the threshold, but still higher levels of concentration. And in the King neighborhood, you have a mixture of both right at the threshold value and higher concentrations, but below the threshold value. And in the Lentz neighborhood, again, you're seeing higher concentration levels, but only a few of them are actually above the threshold. And for the purposes of conserving time and to ensure I'm staying within the allotted 15 minutes, I'm only going to show you the results of one intersection of the micro level analysis, and that is the Southeast Grand Avenue and Southeast Belmont Street intersection. So in 2015, within that 250-foot distance band, you had concentration levels that were close to 3 and even above 3. 200 to 500-foot distance band, again, you had intimidation was below, aggravated and simple assaults were above. So you're seeing a greater degree of variation. 2016 results quite significantly higher for simple assaults and intimidation within that 250-foot band. And here for 2018, you're seeing most of them are below that significant threshold level. And for 2019, they are all below the significant threshold, and there are even values that are less than, less than 1, and even a value of 0. So my conclusion from this project was that the macro level results show concentrations of assault crimes are 2.4 to 2.8 times higher within the 500-foot buffer of transit nodes compared to the entire city of Portland. And the meso and micro levels results were less conclusive. There wasn't any consistent pattern of higher concentration levels. And the analysis of smaller geographic spaces had greater variations in the results. Limitations of the crime data becomes more apparent at large scale analysis. So when you're looking at that micro level, you're looking at small geographic spaces, but the limitations with the data is just more apparent. And the large number of unusable incident data possibly skewed the results. And my analysis only considered the spatial proximity of crimes to the transit nodes. It did not consider other factors. So in my conclusion, I believe that other contributing factors should be studied to look at what else could be explaining the pattern of distribution of these violent crimes near or around the transit nodes. And that concludes my presentation.